Hello, I'm Tyler Greenhill. The topic of my project is the alternative fuels that fleet vehicles utilize. Fleet vehicles can range from compact vehicles such as forklifts and cars all the way to large full-size trucks. The size of a fleet can range from just a few vehicles to over thousands of vehicles, many of which are designed to perform special tasks and are equipped with special equipment to complete these tasks with. This can present challenges when integrating alternative fuel technology into the vehicle because of space constraints. Most experience heavy usage more than what most standard vehicles will see. Some advantages fleets have is many have their own service garages, which do reduce cost, and many have their own on-site fueling stations for not only gasoline and diesel, but for alternative fuels such as CNG, LPG, and electric vehicle chargers, which saves cost. And they do have more possibilities to utilize alternative fuels because their revenue allows them to invest more in the fuels, and they have access to the fuels when compared to private individuals who do not have the money or the easy access to the fuels. The heavy vehicle usage allows them to quickly recover the higher initial cost of purchasing an alternative fuel vehicle compared to a private individual who may never make up the cost of purchasing a hybrid over a standard vehicle. The fleet usage also provides a good testing environment for various fuels and propulsive systems. Manufacturers do work with fleets to test their products and get feedback about the performance of their products and technologies so they can improve current vehicles and then develop new vehicles which they can then sell to the fleet and individuals. Some of the fuels currently utilized are CNG, LPG, electric vehicles, also gas and electric hybrids. Some of the alternative fuels that are undergoing testing by fleets are hydrogen fuel cells and hydraulic hybrids. Some fleets that utilize alternative fuels are commonly known USPS, UPS, FedEx, and Waste Management. There are more that do use alternative fuels, but these are the most commonly known ones. USPS, this is a photo of the Grumman Long Life vehicle, which has served USPS for over 25 years. Its age and high use have really worn down on these vehicles, and many of them need replaced. So this is a chance for USPS to integrate more alternative fuel vehicles into its fleet. Right now, USPS operates over 200,000 fleet vehicles, many of which are flex fuel, some propane, quite a bit of CNG vehicles. They're starting to get more hybrids. They are testing EVs in the cities, one being the Navistar E-Star step van, which they're using in New York. And then they are testing a Chevy Equinox fuel cell vehicle and providing feedback on it for General Motors. UPS, this is a picture of the hydraulic hybrid UPS is testing. It's not much different from their current vehicle. The biggest difference is what's underneath. UPS uses a lot of CNG. They're getting into LPG quite a bit. They do have some propane. It has a lot of its own fueling stations. And it also operates one of the largest LNG networks that's privately owned. Hydraulic hybrid technology is something UPS is getting into. Some basics on it is it operates very similar to a gas electric hybrid. The system comprises of different components though. It has two accumulators, one for high pressure and then a low pressure reservoir, a pump, the hydraulic motor which is used to power the wheels, and then the hydraulic fluid. A parallel system, the engine can power the wheels when needed, but in the series system the engine is never coupled to the drivetrain and runs only to pump pressure into the system. And the series is a more efficient system over the parallel in stop and go conditions, but the parallel will do better when the engine is needed and can be coupled to the drivetrain when sustaining high long-term cruising speeds. The UPS hydraulic hybrid itself is a series hybrid which only uses the engine to pressurize the system when the system pressure is low. Its regenerative braking system can recover 70% of braking energy compared to a electric hybrid which may only do around 30%. And this vehicle operates very well in urban stop and go conditions, which is what UPS trucks undergo the most of. Here's an illustration of the components used in the hybrid. It's got the high pressure accumulator which stores high pressure fluid, and then the low pressure reservoir will store the low pressure fluid. The engine turns the pump which will pressurize the system when needed, and then the pump is used to push the fluid into the back to drive the motor which will spin the wheels in the rear. Another technology starting to make its way into vehicles is the compressed air engine. It's very similar in design to an internal combustion engine, but the camshaft profile is designed for the two-stroke cycle instead of the four-stroke. So it injects compressed air to the cylinder, which pushes the piston down on the first stroke. And then when the piston starts going up on the second stroke, the exhaust opens up and blows that compressed air into the atmosphere. It does require much less maintenance than a standard internal combustion engine because there's no fuel to burn, so there's much less heat. Also, with no fuel to burn, there's less contamination to the oil, so the oil life is much longer. There's also practically zero tailpipe emissions. The only emissions are the compressor oil that is pumped into the vehicle during fill-ups from the filling station. Some applications to compressed air can be used as small forklifts and also small compact trucks, which are used within a facility or inside a building. They are great for inside buildings because the emissions is almost zero, so it presents a much healthier work environment for employees. They're very cheap to operate, and the filling equipment is simple and inexpensive. Some of these vehicles you could just use a standard compressor, but it takes much longer than purchasing a proper filling station, which will have compressed air tanks so that the vehicle can be filled within 5 minutes or less. Here's an example of Peugeot's hybrid air car. This is one of the largest applications that uses a compressed air engine. There's a tank in the rear and a tank in the middle that are used to power the engine, and there's also the hybrid system. And then what the future holds for these fleet vehicles is new technology and manufacturing processes have reduced the cost of the alternate fuel vehicles, and many aging fleets are in need of replacement vehicles. So this is a chance for these fleets to invest in alternative fuel vehicles to not only save money but help clean up the environment compared to using standard vehicles. Thank you for your time.